Welcome to today's GATE video. I am Sasikala, working as an assistant professor in the Department of CSE of S.A.ENGG.COLLEGE. Today I am going to discuss about stack, operations of stack, applications of stack. So stack is a linear data structure that follows the last in first out principle, where the last element inserted is the first one to be deleted. So the example of stack is, it behaves like a stack of books where the last book added will get removed first. So here in stack we have two conditions will occur. So one is call it as underflow and the next one is overflow. So underflow condition is nothing but if you try to pop an element from an empty stack, so this condition will occur. And overflow condition is a condition where the element is pushed into the stack. If the stack is full, so this condition will occur. And stack has only one end, so that end is called it as a top, where both the insertions and the deletion will take place. And we will see about the operations of stack. Okay, first function is push function. So the push function is used to insert or deleting and inserting or adding an element to the top of the stack. So before inserting an element into the stack, we have to check whether the stack is full or not. If the stack is full and if you try to add an element into the stack, so a condition will occur. So that condition is called it as overflow condition. So if the stack is not full, then we can insert the new element. After inserting the new element, the top pointer will get incremented. So the next function is pop function. So the pop function is used to remove and return the topmost element from the stack. So before deleting an element from the stack, again you need to check if the stack is empty or not. If the stack is empty and if you try to delete an element from the stack, the underflow condition will occur. So if the stack is not empty, then you can remove the element at the top and the top pointer will get decremented. So the next function is peak function or the top function. So this function is used to return the topmost element of the stack, so without removing it. So you have to check whether the stack is empty. So if the stack is not empty, then it will return the topmost element of the stack. So the next function is the size function. So the size function will return the size or the number of elements in the stack. So it doesn't modify the stack, it only tells how many items or the elements are present in the stack. So the next function is empty function. So this function will return true if the stack is empty, else it will return false. The last function is full function. So this function will return true if the stack is full, else it returns false. So next we will see about the applications of stack. So the first application is, it is used for evaluating the expression. So stacks are used to evaluate the postfix expression, prefix expression, and to convert infix to postfix and conversion of infix to prefix. So the next application is backtracking. So stack helps to return to the previous state when it doesn't have a path. So the examples for backtracking are maze solving, n-queens problem, Sudoku solving, and DFS. So DFS is depth first search. So next, stacks is used in these applications. So in these applications, okay, so these applications use stacks to maintain the history. So next one is, stacks are used to allocate and deallocate the memory automatically, and then it will manages the flow of execution of the program. So next application is string reversal. So stack is used to reverse the strings because it is having the LIFO order, that is last in first out. So if you give the input as stack, so it will return the output as KCATS. So next we will see the application of evaluation of postfix expression. So these are the steps which is used to evaluate the postfix expression. So the first one is you have to scan the postfix expression from left to the right. So while you are scanning the expression from left to right, if the symbol is an operand, then you have to push it onto the stack. The next step is if the symbol is an operator, then you have to follow these steps. That is, you have to pop the operand 2, pop the operand 1, then you have to evaluate, that is, you have to do the operations based on the operator. Then you will have the result. That result has to be pushed back onto the stack. Then the next step is you have to continue the above steps until the end of the expression. So then finally you will get the result, and that result will be the top of the stack. So this is an example for evaluation of postfix. So 6, 3, 2, asterisk, plus 5 and minus. So in step 1, the first thing is you have to evaluate the expression from left to right. So if the symbol is an operand, so here in the given example, the first symbol is an operand. So if it is an operand, you have to push it onto the stack. Again, go to the next symbol. So again, next symbol is also an operand, push it onto the stack. So next one is, again it's an operand, push it onto the stack. So next we have an operator. So once we have an operator, so we have to pop out the top 2 elements and we have to perform the operation based on the operator. So here we have an multiplication operator. So take the value of the top 2 most elements are 6. So you have to top 2 elements are 3 and 2. So multiply with the operator. So you will get the result as 2. So after getting the result, so you have to push it onto the stack. So next, so we have an operator plus. So now in the stack we have 2 elements, 6 and 6. So once we have an operator, then we have to pop the first two topmost 2 elements, then do the operation. Here the operation is plus. So add these 2 elements. So we'll get the answer as 2. Then this result has to be again pushed on to the stack. So now in the stack we'll have 2 elements, 12 and 5. And next we'll have an operator. So in the question we have an operator minus. So do the operation subtraction for the topmost 2 elements, that is 12 and 5. So if we subtract 12 minus 5, so we'll get the result as 5. Again we have to push it onto the stack, and this is your final value for the above problem. So now, next we'll see a problem, get questions. So the first question is, the 5 items A, B, C, D and E are pushed on in a stack, one after the other, from A. The stack is popped 4 times and each element is inserted in a queue. The 2 elements are deleted from the queue and pushed back on the stack. Now one item is popped from the stack and we have to find out what is the popped item. So in the given question, so first thing is they have 5 items A, B, C, D and E. So in a stack we are having only one end. So push all the 5 items into the stack one by one. A, B, C, D and E. So next the stack is popped 4 items and each element is inserted in a queue. Now we have to pop the 4 items from the stack and those items should be inserted in the queue. So before that we should know what is queue. Queue is again, it is also a linear data structure that follows FIFO principle. FIFO is first in, first out, which means the first element which is inserted will get deleted first. So this queue has 2 ends, one is called it as rear end and the other is called it as a front end. So in the stack we have only one end, that end is called it as the top where insertion and deletion takes place. But in queue we have two ends where insertion will occur in the rear end and deletion will take place in the front end. Okay, so here in the question, so they have given, so we have to push 5 items into the stack, and after inserting, so we have to delete 4 items from the stack, and those items should be inserted in the queue. So now we are going to pop 4 items from the stack. So first item is E, so insert into the queue. Then the second item is D, third item C, and fourth item is B. So now we have inserted all the 4 items into the queue. So the next is the 2 elements are deleted from the queue, okay, and pushed back onto the stack. So after deletion, okay, after popping, so we have only one element in the stack, that is A. So here in the queue we have inserted 4 elements, and in the question they have given the 2 elements are deleted from the queue. So here in queue, from the front end we have to delete the elements. Okay, so first element is E gets deleted, then D gets deleted, and these 2 elements should be pushed back onto the stack. So the deleted element should be pushed onto the stack. So E and then D. So now we have 3 elements in the stack, that is A, E and D. So next the question is, now one item is popped from the stack. So from the stack you have to pop out one element. So here the topmost element is D. So this element get popped off from the stack, and in the question they have asked which element is popped from the stack. So now the popped item is D. So your answer will be D. Okay, next second question is, consider the following sequence of operations on an empty stack. So they have given some elements and also they have given the pop function. So the first element to be pushed onto the stack is 54. Then again we have to push 52. So 52 is inserted into the stack. Then we have to do a pop function. Okay, that means we have to delete the topmost element from the stack. So 52 gets deleted from the stack, and now the element which is available in stack is 54. Then again we have a push function. We have to push 55 into the stack. Then again push 62. Then finally we have again a pop function, S is equal to pop, which means we need to delete a element from the stack. So 62 gets deleted from the stack, so the value of S will be 62. So next NQ. So NQ means inserting an element. DQ is deleting the element from the queue. Okay, so NQ and DQ. Queue, and this is stack, and in the queue we have to, in queue is we should insert an element into the queue. So 21 is inserted into queue. So next again NQ 24, insert 24. So next is DQ. DQ means we have to delete an element from the queue. So the queue works on the principle of FIFO, which means the element which gets first inserted will get deleted first. So the first inserted element is 21, so this will get deleted. So next the element now available in queue is 24. Then again we have to NQ 28, so insert 28 in queue. Again NQ 32, so insert 32 in queue. Then we have a NQ function, a DQ function, that is Q equal to DQ. So DQ means we have to delete an element from the queue. So again this element will get deleted, 24. So this will be assigned for Q variable. So now we have to find out the value for S plus Q. So what is the value of S here? 62. And what is the value of Q? 24. So you have to add the value of S plus Q. So when we add these two values, so we get the answer as 86. So this is your answer for the question. The next question is the result evaluating the postfix expression. So they have given some expression, so we need to find the value of this expression. Okay, so for evaluating the postfix expression, so the first thing is we need to scan the expression from left to right. So from left to right, we have to scan the symbols. So here the first symbol is an operand. So if it is an operand, we need to push that operand onto the stack. So 10 is pushed onto the stack. So the next is 5, again it is an operand. So push it onto the stack. So next we have an operator. So if the symbol is an operator, so we need to pop the top two element from the stack and do the addition operation. So 10 plus 5, which is equal to 15. So we have got the answer as 15. So once we got the result, then the result should be again pushed onto the stack. So 15 is pushed onto the stack. Then again scan the expression. So again next one is an 60 is an operand. So if it is an operand, so you have to push it onto the stack. Next go to the next symbol. Again it is an operand. Push it onto the stack. So next one is we have an operator. So if the symbol is an operator, so we have to pop the topmost two elements from the stack and do the division operation. That is 60 divided by 6, which is equal to 10. So now we have got the result as 10. So this result has to be again pushed back into the stack. So now in the stack we have two elements 15 and 10. Again scan the expression. So next we have a next symbol is an operator. So if the symbol is an operator, we have to pop the two elements from the stack, top two elements from the stack and do the multiplication operation. So 15 into 10 equal to 150. So after getting the result, so this result has to be pushed back onto the stack. So now we have got the result as 150. Then again scan the expression. So next symbol is an operand. So if it is an operand, so you need to push onto the stack. Then again scan the expression. Then we have an operator. So if the symbol is an operator, we need to pop the topmost two elements from the stack and perform the operation. That is 150 minus 8, which is equal to 142. So this is your final answer, 142. Okay, so next question is, the following postfix expression with a single digit operands is evaluated using a stack. Note that this cap is an exponentiation operator. The top two elements of the stack after the first asterisk is evaluated are. So we need to we have to evaluate the given expression and we need to find the top two elements after the first asterisk is evaluated. Okay, so this is a question. 8, 2, 3 exponentiation operator, then slash 2, 3 multiplication plus 5, 1 again multiplication and minus. We need to find the top two elements from the first asterisk is evaluated. So first thing is scan the expression from left to right. So here the first symbol is an operand, so push it onto the stack. Again we have an operand, push it onto the stack. Next is also an operand, push it onto the stack. Then next symbol is an operator. So if you are getting an operator, so we have to pop out the top two most elements and do the exponentiation operation. So 2 exponent of 3, which is equal to 8. So now we have got the result as 8. Then this result has to be again pushed back onto the stack. So now in the stack we have two elements, 8 and 8. So again scan the expression from left to right. So next we have next symbol is an operator, that is division operator. So if the symbol is an operator, again we have to pop the elements from the stack, perform the division operation. So now we got the result as 1. So after getting the result, so we have to push back the result onto the stack. So next is again on operand 2, push it onto the stack. Next one is operand, push it onto the stack. So next is an operator. So next symbol is an operator. So if it is an operator, then you have to pop out the first top two most elements from the stack, then do the multiplication operation. So 2 into 3 equal to 6. Then this value will again push back onto the stack. So in the question they have given, so once the first asterisk operator is evaluated, so what are the top two most elements which is available in the stack? So this is your question, and the top two most elements are 6, 1. So this is your answer for the above problem. The next question is, consider the operator precedence and associativity rules for the integer arithmetic operators given in the table below. So they have given the table with the operator precedence and the associativity, and also they have given the expressions. We need to find the value for the above expression based on the precedence and the associativity which is given in the question. Okay, so here the highest precedence is plus operator and associativity is left, which means we have to evaluate the expression from left. So next operator is minus. This is having the next priority, and the direction to evaluate is right. Then multiplication medium and division is low. So based on these precedence and associativity, we have to evaluate the expression. Okay, so this is your question. 3 plus 1 plus 5 multiplication operator, 2 division operator, 7 plus 2 minus 4 minus 7 minus 6 division operator 2. So the first operator which they have given in the question is plus minus multiplication and division. Okay, so this is the order. So this is left, right. Plus operator, minus, multiplication and division, and the associativity is left, right, right, right. Plus, minus, multiplication, division, left, right, right, right. Okay, so now we can evaluate the expression. So first is 3 plus 1. So since plus operator has the highest precedence, so we have to evaluate the addition operation. So that is from left. 3 plus 1. 3 plus 1 plus 5. 2 by 7 plus 2 minus 4 minus 7 minus 6 by 2. Okay, first we have to do the addition operation since it is having the highest priority. So 3 plus 1, 4, 4 plus 5, again plus, so 4 plus 5 is 9, So next again we have the plus operator. So 9 into 2 divided by 7. 7 plus 2 is 7 plus 2, 9, minus 4, minus 7, minus 6 by 2. So the next precedence is subtraction. So if it is a operator is a subtraction operator, then the direction which we have to evaluate is from right to left. So we have to evaluate from right. So 9 by 2. So here we have to evaluate from right. 9 minus 4 minus 7 minus 6 is 1 by 2. Next again we have a subtraction 4 minus 1. So divided by 9. Minus 4 minus 1 is 3 by 2. Next again 9 into 2 divided by, again we have a subtraction operation. So 9 minus 3 is 6, 6 by 2. So the next priority is multiplication operator. So we need to perform the multiplication operation. So 9 into 2 is 18 by 18 by 6 by 2. So the next priority is division operation. So the associativity is right hand side. So from right we have to evaluate. So first we need to perform 6 by 2. So 18 by 6 by 2 is 3. So again 18 by 3 is 6, and this is your final result. Thank you. We will continue on the next video.